Hey everyone, this is part 1 video on past year NEET questions from the topic surface chemistry. We'll start with a question that has come in the year 2019. Which mixture of solutions will lead to the formation of negatively charged colloidal AgI I-? So the I- is the negative layer of iodide ions formed on the colloidal particles of silver iodide. So if you look at the formation of negatively charged layer, we must have the iodide ions in excess, but it should be a slight excess of the iodide ions present. So if we look at the 4 options given to us, we are mixing AgNO3 with potassium iodide in different concentrations. So we must have the mixing happening in such a way that the Ki amount will be in slight excess. Thereby what happens is, after when we mix the Ki with AgNO3, that will lead to formation of AgI, plus there will be some amount of excess I- ions, and that is going to be forming the negatively charged layer on the colloidal particles. So the idea is, if we are preparing a colloidal sol of AgI by mixing Ki solution with AgNO3, the Ki should be in slight excess. As a result of this, the I- ions will be adsorbed on the surface of AgI formed, and we will be getting the negative sol. So if we look at the options one by one, option A, 50 ml of 0.1 molar AgNO3 and 50 ml of 0.1 molar Ki. So here AgNO3 and Ki, they are exactly in proportion, so this will not be suitable. Option B, 50 ml of 1 molar AgNO3 and 50 ml of 1.5 molar Ki. So here we can see that the Ki is in excess, but it is in slight excess. Option C, 50 ml 1 molar AgNO3 and 50 ml of 2 molar Ki. So this is almost double. The amount of Ki is double that of the amount of AgNO3. This is in very much excess. So this will not be also suitable. Option D, 50 ml of 2 molar AgNO3 and 50 ml of 1.5 molar Ki. Here AgNO3 is in excess, so this also will not be suitable. So the correct mixing proportion that will give us negatively charged sol will be option B, which is 50 ml of 1 molar AgNO3 and 50 ml 1.5 molar Ki. Moving on, the question that has come in the NEET 2019 paper, this is based on Freundlich adsorption isotherm. The correct option representing the Freundlich absorption isotherm is, so if you look at the Freundlich absorption isotherm at constant temperature, that's why they are called as isotherms. The amount of adsorption, which is measured by the mass of the adsorbate per given mass of adsorbent, will be equal to K into P power 1 by N, where the value of N will be more than 1. So if we look at the representation, this is how it is going to be. So we see a curve where the extent of adsorption will reach the saturation level, where the N value will keep increasing and it will go up to infinity. Thereby once it reaches saturation, the X by M value is going to be independent of the pressure. So if you look at the value of 1 by N, 1 by N initially will be in the range of 1, that's why it is a straight line, and it will be going up to 0. So N value accordingly will be increasing from 1 to infinity. So 1 by N value will be changing from 1 to 0. So 1 by N value, the power of pressure should be in the range of 1 to 0. So if you look at the options, only option A, the power of P is 0.3, which is in the range of 1 to 0. So the correct equation that represents the Freundlich adsorption isotherm is X by M is equal to K P power 0.3. Next we have a question that has come in the 2018. On which of the following properties does the coagulating power of an ion depend upon? So the coagulating power of an ion basically is determined by the Hardy-Schulze rule, which states that if greater the valency of oppositely charged ion, then the faster will be the coagulation. Means charge value is going to be determining the coagulating power, and also the ion must be oppositely charged. So here the basic principle is the electrostatic force of attraction between the charge on the colloidal particles and the charge on the ions. So the coagulating power will be depending upon both magnitude and the size the sign of the charge of ions. Only we will be able to use oppositely charged ions for the coagulation. Next we have a question that has come in the NEET 2017. Which one of the following statements is incorrect? So these statements are relating to the use of a catalyst. Option A is saying that the value of equilibrium constant is changed in the presence of a catalyst in the reaction at equilibrium. This is in fact incorrect. The use of catalyst will not change the equilibrium constant. It only makes the attainment of equilibrium faster. So the incorrect statement is option A. We'll go through the other options also. Option B is saying that enzymes catalyze mainly biochemical reactions. That is the reason why we also call enzymes as biocatalysts. So this is the correct statement. Coenzymes increase the catalytic activity of enzyme. In some particular cases, we also have coenzymes that basically increase the enzyme activity. So this is also correct statement. Option D is saying that catalyst does not initiate any reaction. That is also correct, because the catalyst will only be able to speed up the reaction that is already happening, but it will not be able to initiate any reaction as such. So the incorrect statement is option A, which is saying that a catalyst can change the equilibrium constant. Next we have a question that has come in the NEET paper 2 2016. The coagulation values in millimoles per liter of electrolyte used for the coagulation of AS2S3 are given below. So coagulation values are basically the amount of electrolyte that is required in concentration terms that will be able to coagulate a given leophobic colloid. So here the coagulation values of the electrolytes are given as sodium chloride it is 52, barium chloride it is 69, and magnesium sulfate it is 0.22. The correct order of their coagulating power is, so if you look at the coagulating power, it is a measure of how an electrolyte will be able to coagulate a particular sol. So if the coagulation value is lesser, then the coagulation power will be more, because with small amount of the electrolyte we will be able to coagulate a given sol. So lesser the coagulation value, higher will be the coagulating power. And the comparison of the coagulation values here, we can see that the MgSO4 with coagulation value 0.22, that is the least, will have the highest coagulation power. Then comes barium chloride, then comes sodium chloride. So sodium chloride, the coagulation value is highest, so coagulation power will be least. So the relation will be reciprocal. So the correct order of coagulating power will be MgSO4 more than barium chloride more than sodium chloride. 3 greater than 2 greater than 1. Option C is the correct statement. Next we have a question that has come in the year 2016 paper 1. Fog is a colloidal solution of. Now fog is an example of aerosol, where we have the dispersed phase of the liquid particles in the medium of gas. So it is an example of liquid in gas type of colloidal solution. Option C is the correct answer. Next we have another question that has come in the 2016 paper 1. Which one of the following characteristics is associated with adsorption? So they are talking about the del G, del H and delta S. If you look at any adsorption process, the particles are coming and settling. The particles of adsorbate are coming and settling on the particles of adsorbent, which means this process will be a negative entropy process. So when they are in the gas medium or liquid medium, they'll have a higher degree of freedom, and when they are coming and settling on the surface of adsorbent, the degree of freedom will be reduced. So the adsorption process will be entropy negative process. And adsorption is a spontaneous process. When we say spontaneous process, for all spontaneous process, the free energy change delta G must be negative. And if you look at delta G, which is equal to, when we maintain the temperature constant, delta G will be delta H minus T delta S. We are looking at delta G negative, and already delta S is negative. So minus of minus will be overall, it is going to be plus, positive. Now in order to have del G negative, the adsorption must actually have the enthalpy change delta H must be negative. It must be so much negative that it will be more than the positive value of this. So which means we have delta S negative, delta G negative, and delta H also must be negative. So all the three terms should be negative for the adsorption process. Next we have a question that has come in the 2015 cancelled paper. Which property of colloidal solution is independent of charge on the colloidal particles? Now if you look at the phenomena that are given here, electroosmosis, coagulation, electrophoresis, they all depend upon the charge value. Charge, both the sign of the charge and also the magnitude. The effect that does not depend upon the charge will be Tyndall effect. So Tyndall effect is basically the scattering of light by the colloidal particles. So this has no correlation to the charge of the colloidal particles. Option B is the correct answer. Next we have a question that has come in the year 2012. In Freundlich adsorption isotherm, the value of 1 by n is. So in fact we have seen already one such question before. If you look at the Freundlich adsorption isotherm, the expression is x by m, the extent of adsorption or the measure of amount of absorption will be equal to k into p power 1 by n. The value of 1 by n will be in between 0 to 1. So if you look at the way the value of 1 by n will change, initially the value of 1 by n will be 1, so we have almost a straight line relation, and as we reach the saturation value of adsorption, the value of 1 by n will become 0. So the range for the value of 1 by n will be between 0 to 1 in all the cases.